Section 6.2 involves multiplying and dividing rational expressions. In the first problem, we want to multiply as the problem indicates. When multiplying rational expressions, one of the first things we want to do is make sure each numerator and denominator is completely factored. So I'm going to factor a 3 out of 3x plus 9. Obtaining 3 times the sum, 3x plus 3. In the denominator, I want to factor, I noticed that the greatest common factor, which is what I should always look for first when factoring, is 2x. So I'm going to factor that out, and I have to multiply 2x times x to obtain the first term of x squared. And then 2x gets multiplied by negative 3 to obtain the second term of negative 6x. So 2x times negative 3 gives me negative 6x. Similarly, I'm going to factor x squared minus 3x. The greatest common factor here is x, which multiplies by x to give me the first term of x squared, and by negative 3 to give me the second term of x squared minus 3x. And then in the final denominator, I have a GCF of 5, which multiplies by x to give me the first term of 5x, and it multiplies by a positive 3 to give me the second term of plus 15. So in each case, in this problem, the factorization needed was the factorization of a greatest common factor. So now I am going to divide out any factors in the numerator that are also in the denominator. So when I divide this x plus 3 in the denominator into this x plus 3 in the numerator, I get a 1. And as long as there are other factors that still remain, I can leave that 1 unwritten. When I divide the x minus 3 in the denominator into the x minus 3 in the numerator, I get another 1 that I'm going to leave unwritten. And when I divide the x in the denominator into the x in the numerator, I also get 1. Now, I would have to write at least one of these factors of 1 if there were no other factors remaining, but I noticed that there is a factor of 3 left in that numerator. And in the denominator, I have a factor of 2 and a factor of 5. So this problem winds up being 3 divided by 10. Now, one of the things we've assumed in the problem is that no expression was equal to 0. Since we can never divide by 0, we would not have been able to complete the division if x plus 3 was 0, or if x were 0, or if x minus 3 were 0. So in these problems, in 6.2 on, we are going to assume that none of our expressions involving the variable ever equal 0. In the next problem, we're also multiplying two rational expressions. This time, our factoring is going to be a little more involved. So when I factor the first expression's numerator, that factors into x plus 2 times x plus 2. And if you don't see that right away, work on scratch paper. If you're taking an exam, work on the back of a page of the exam different from the page the problem is on, and figure out the factors, and then bring your results back to where you're working the problem. Now, I look at this denominator and I realize the first factoring that I need to do here is to factor out a GCF of 3. So 3 multiply by x squared plus x minus 6 would multiply back to give the original expression. So I should always look first for the presence of a greatest common factor, a GCF. In the second expression, there is a GCF in this numerator of 5 that multiplies by x squared minus 9 to give me back that original numerator. And then the denominator is a trinomial that factors into x minus 5 times x plus 2. Now, the first numerator is already completely factored, but I have one more factorization I can do on the first denominator. X squared plus x minus 6 factors into x plus 3 times x minus 2. And again, if you don't see that right away, use scratch paper. If you're taking an in-class exam, use the back of another page of the exam and figure out the factorization. Bring the result back to the problem. X squared minus 9 is a difference of squares, and that factors into x minus 3 times x plus 3. And I'm recopying the second denominator because that was completely factored. So that's my factorization of each numerator and each denominator, which are now all in completely factored form. So this x plus 2 in the second denominator divides evenly, giving me a 1, into the x plus 2 in the first numerator. And notice what I'm doing is division. X plus 3 in the first denominator divides one time into x plus 3 in the second numerator. And there are no other common factors. So my final answer here is x plus 2. And I see I have a 5. I put my monomial factors first. So this 5 comes in the front, and then the x minus 3. So that's my numerator after I've divided out all common factors. And my denominator is 3 times x minus 2 times x minus 5. And so this is my final answer. This is in its most simple form. There's no need for me to multiply these factors out. In these problems, any factors that remain are left in factored form. So that would be the complete work for problem 2. Now with the division, I'm always going to change that to a multiplication. A over B divided by C over D, and this is something that you learned a long time ago, and you get to remember that fact, or this fact, is equal to A over B times D over C. So the polynomial that you are, or the rational expression you're dividing by, is inverted when you change this to a multiplication. So notice there's no change to what you're dividing into. That remained as A over B. But what you're dividing by is changed to its reciprocal when this is changed to a multiplication. And that's what I'm going to do here. And I recommend doing this first. Otherwise, it's easy to forget to do it. If you start factoring, that's really not a problem as long as you don't forget to do the inversion. So I'm going to just do the inversion as a separate step so that sometimes you can get so involved in the factoring you can forget to change this to a multiplication and invert what you were dividing by. So I'm going to do that right away so that I don't forget. And now I simply need to factor. And again, if you don't see the factorization right away, the first numerator factors into y plus 2 times y plus 2. If you don't see that right away, then go to a piece of scratch paper in an in-class exam. That would be the back of one of the other pages. You can always pull your pages apart and figure out the factorization and bring that result back to your problem. Don't clutter your problem up with all your thinking for your factoring. So the first denominator factored into y minus 7 times y plus 2. The second numerator factors into y minus 5 times y plus 4. And the second denominator factors into y plus 4 times y plus 2. It's important to make sure you have the factorization correct. Now, I recommend factoring whichever numerator or denominator you most readily see the factorization for. So say, for instance, you see right away that the second denominator factors into y plus 4 times y plus 2. Then go ahead and factor that first. That will give you some clues on what the factors to the other numerators might be. You factored a denominator, you suspect that maybe one of those factors is a part of either of the numerators. It's not a guarantee, but it guides you a little bit on your factorization. So always do the factorization that you feel is easiest first. So I see that this y plus 2 in the denominator divides one time into this y plus 2 in the numerator. And this y plus 2 in this denominator divides one time into the y plus 2 in the first numerator. And then I have this y plus 4 in the denominator that divides one time into the y plus 4 in the numerator of the second expression. And I am left with y minus 5 over y minus 7. And notice these y's are not factors. They're terms. This y is being added to negative 5. This y is being added to negative 7. So you cannot divide those out. Those are terms. You can only multiply and divide factors. So this problem is completed. My last problem is also a division. And I notice with this first numerator that the problem is written in a way that I'm going to change. I'm going to factor out a negative because I always want my leading coefficient to be positive, and I can always make that happen by factoring out a negative if necessary. When I'm factoring, this is something that I would do when factoring. So every term changes sign, and I'm also going to change the order. You just want to check that if you multiply negative 1 times y squared, do you get negative y squared? Yes. Negative 1 times negative 6y gives positive 6y. Negative 1 times negative 16 gives positive 16. In the bottom of the first expression, I can factor out a 3. A GCF of 3. So I'm going to go ahead and do that now. And then 3 times 64 would give me that 192. And I'm also going to change this to multiplication by inverting what I was dividing by. And now I'm simply going to compute my factors. Here, so remember, factor whichever one seems easiest first. So maybe you look at that bottom, and that difference of squares, y squared minus 64, seems easiest to you. Factor that first. That factors into y minus 8 times y plus 8. It doesn't matter what order you have the factors in. I could have written y plus 8 times y minus 8. Now that leads me to think that maybe in this numerator, I'm going to either have a y minus 8 or a y plus 8. Turns out it is a y minus 8 that gets multiplied times a y plus 2. So always factor the expression that you think is easiest to factor first. Always do that first. All right, now I'm going to suspect that I'm going to have a factor of y plus 8 in this numerator, since I have a factor of y plus 8 in this denominator. No guarantee, just a suspicion. It actually turns out this is a perfect square trinomial, this second numerator, that factors into y plus 8 times y plus 8. And then this denominator factors into y plus 8 times y plus 2. And again, if you're having problems with those, do them on scratch paper and bring your results back to the problem. So this y plus 2 in the denominator divides out with this y plus 2 in the first numerator. Y plus 8 in the first denominator divides one time into y plus 8 in the second numerator. Y plus 8 in the second denominator divides one time into y plus 8 in the second numerator.
All right, and then we have the y minus 8 in the first denominator dividing one time into the y minus 8 in the first numerator. And we are left with the negative sign. All factors in the numerator have been divided out, leaving a 1. So 1 times 1 times 1 times 1 is 1. And then there is a 3 that remains in the denominator. So our final answer is negative 1/3.